Okay, good morning, 8 Red. We will be this week beginning where we left off. Pretty much the first 8 questions are just from what you did last week. And then we're going to expand on that. Not sure if you did this type of question or not last week, but let's do one real quick. Writing the recursive formula. It's a 2-part. The first term is 7. And then the nth term is, well, what are we doing each time? We're subtracting 4 in this case. So the nth term is the n minus 1th term minus 4. So let's do it. 7, and then a of n equals a of n minus 1 and then subtract oh, don't you dare put that down there. Okay, so you got to move out and then use your minus 4. Okay, over here, and don't worry about for n greater than or equal to 2. That's just because we put the first one here. So now we're talking about the second one and the third one and so on. So over here we're timesing by 5 each time. The first term is 5. And a of n equals a sub n. See how that's a little sub note there? N minus 1. It's always the one before it that you're talking about. And then use your arrow to get out of the bottom. And then we're going to use the times 5 button. Whoops, I hit 7. Said 5. Okay, so here we go. Oh, I said 5. It's 2. Okay, that wasn't hard to fix. Okay, so then number 10. Now we're talking about functions, exponential functions, which are just, they're going to generate numbers that are a geometric sequence, okay? So when I put in -2 and put in -1 and put in 0, so 1/8 to the -2 is the same as, remember this review from 8th grade, so 1/8 to the -2, same as 1/8 to the +2, same as 1/64. Okay? Remember that? No? I hope you remember that. Hang on a second. This to the -2. Let's erase this. This is the same as 8/1 to the +2. Reciprocate it. It's the same as 8 to the 2. 1/8 to the -1, same as 8/1 to the +1, same as 8. Okay? 1/8 to the 0 is 1. So this is going to be 64, 8, 1, 1/8, and 1/64. Okay, you can use your calculator. You can actually put in the function and generate a table. Is it mod 5.1, mode 5.1, something like that. Or you can just go one at a time and test them. So 64, 8, 1, 1/8, 1/64. So what you're doing here is you're just checking your skills with the numbers and your understanding of this is no longer linear. This table is exponential now. And if you look down the side of it, Yes, I am moving around a lot, but I need to. I gained some weight. I couldn't fit in my work clothes this morning. This is times by 1 over 8. 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 Okay? You follow that? So instead of plus or minus, now we're doing multiply. Never divide. Always multiply by the fraction, kids. It is not division. I know sometimes you'll be tempted to do that, but it does not work. So, a soda can is placed. As the soda cools, its temperature in degrees Celsius after t minutes is given by the following exponential function. And this is how we use these things. Okay, so this is pretty good. Now, remember we had y equals mx plus b. That was linear. Okay, this was our change. This was our beginning, right? Now we're going to use, I'm going to use the same letters. I'm going to steal them for a minute. And think of your BMX bicycle. This is b times m to the x, where this is still the beginning at 0. It's still the beginning at 0, but this is now our multiplier. It is not our slope, it's not our constant of change, it's our multiplier. Okay, I'm spelling bad. That should be an I probably. Okay, I didn't get this job because I was good at spelling. Okay, so the initial temperature, initial, beginning, what you started at, is this number. This is our B. So this would be 23 degrees Celsius. Does the function represent growth or decay? Well, what are we multiplying by? Is this greater than 1? That it's getting bigger? No. If this number was like 1.2 or 1.01 or anything greater than 1, then it would be getting larger. It would be growing. But it's less than 1. It's between 0 and 1. So it's getting smaller, which makes this decay. Okay? And by what percentage does it change each minute? Don't be fooled, it's not 97%. It's 1 minus whatever that rate that we're looking for is. And that's what equals this. 1 minus what equals 0.97. And so we find 0.03, which is 3%. So it decreases, it decays by 3% each time. I hope you're following that. It's really not that hard. It's quite fun once you do it and you understand. Okay? So that's the whole of how the exponential functions are made up. Let's see, is there another one just like that? No, but there's, everything is the same math. So I'm going to write up here y equals bmx, like the bicycles, okay? So here we're going to have to begin 2700. We begin at 2700 bacteria cells. Each hour since the number of cells has increased by 8.3%. It's increased by that. So the number that we're looking for, it's increasing, okay, is 1 plus 0.083, okay, 1.083. That's our M, that's our multiplying number right here. The rate is 8.3%, but our multiplying number is 1, because we have 1 times as much as we had, and then this much more. That's why we have to add that there. So our exponential function is going to be y equals, do they tell us y and t? Okay, so in this case, we're not using an x, we're using a t, and we're going to write 2700. Don't forget to write y equals 2700 times, put it in parentheses, 1.083, close your parentheses, and raise it to the t power. Okay? You following me? BMX. So if we had the first hour, if they didn't tell us the beginning, but they told us the first hour, how many there were, we'd have to put a little -1 up here. But that's not the case yet. So let's just try this. Yay! Is anybody else happy when I get one right? I know I am. Okay, so let's look. Let's see if we can do another one. There was a sample of 750 milligrams of a radioactive substance to start a study. B, 750. Y equals B, 750. Okay, since then the sample has decayed by 7.8%. That means 1 minus 0.078, which is, yeah, I know, I shouldn't use a calculator, but it's been a long day. And 1 minus 0.078, and it's only 11 o'clock in the morning. 0.922. Okay, so 0.922 to the t power. Do I have to put it in, or do you trust me? Y equals 750 times 0.922 to the t power. Correct. Okay, so let's find a different kind of problem here. Okay, so these are examples of scatter plots that are not linear, they are exponential. And as you can tell, they're decreasing, okay? And it wants us to show which is the better model for the scatter plot. Is it linear? Is that better? Is it quadratic? Or is it exponential? And obviously, it's exponential. I mean, you know, these are not that hard. So figure 3, use the equation for the best fitting curve. Here's the equation in the bottom of the box to answer after 70 days. So you're going to put a 70 in here. So 516 times 0.98 raised to the 70 power equals 125, does it say round your answer to the nearest hundredth, 0.45. 125.45. 125.45. I hope that you're not upset about doing these things that you haven't done before. I just thought you were getting bored with the same old, and this isn't hard for you to learn. I'm pretty sure you were learning this no problem. Okay, table of unordered pairs for an exponential function. So BMX, remember? BMX, okay, what's it multiplying? Times 4, times 4, times 4. What's that 0? 8. Y equals. Y equals 8 times 4 to the x power. Okay? I'm not going to take the time to keep putting them in because I don't want to keep you here in the video all day. But trust me, that's how you do that. Okay? So, $44,000 borrowed for 9 years at a 6% interest, compounded annually. That means every year you pay the interest. They figure out what the interest is once a year. That's what compounded annually means. If the loan is paid in full at the end of that period, how much must be paid back? Well, BMX, y equals 44,000 times 6%, it's added to it. Okay, that's 1.06. And for 9 years, to the power of 9, 44,000 times 1.06 to the 9th power equals 74337.07. Round it to the nearest dollar, 74337. 74337. You thought I was going to be wrong. $30,000 interest paid after 9 years. That's why you don't want to leave your balance on your credit card. Credit card interest is 12 or 18 or 22% or even more. Okay, so you leave a balance on your credit card and all you're going to be paying is the interest, and you will always owe that balance. Never make minimum payments. Always pay more than that. Okay? So here, 3,200 covers an area, 32. Suppose each year this area is decreased by 5.25%. So you have 3,200 times 0.9475 raised to the 8th power. Okay? These are fun. Okay? Another one just like it. Have fun with it. I will see you in the morning. Thank you, Red. You're awesome.